Hi, and welcome to our seminar today. We're going to be talking about the globally distributed data cache built on edge computing. Today I'm going to start with what's the status quo? What's the cloud, the Internet of Things, smartphones, and how things are right now. So we've had an explosion of Internet of Things. There's devices, small and big. You can find them in your appliances. You can find them in your vehicles. You can find them even in industry. So manufacturing industries, consumer businesses all over the place are using these devices. And smartphones, they've now become mainstream. Even if you go to developing countries, you can see that people from all different classes have these devices, sometimes multiple devices. It's gotten to a point where you can just assume, almost take it for granted that a smartphone will be in the hands of most of the citizens of a country. So what's the point of all this? Well, the internet's becoming democratized. You've got these devices all over the place. It's no longer limited to the users in traditional Western industrialized nations. These devices are all over the place. So what is the edge? That's what we're talking about today, right? So there's lots of definitions of what it is. I'm going to first give you a little diagram here to show you what we mean by that. So what you see right now on the screen is a single client computer. Think of it as somebody on the web or somebody playing a game. And they're located in this place in the world and they're trying to access data. Now, the traditional way they would access data, let's say that data was sitting in North America. They'll be pulling that data over from a server all the way on the other side of the Atlantic. It's going to take quite a while. So what we're going to do now is we're going to show this new icon on the right, and that is the edge cache. So that's the Bluzelle edge cache. You can see it's a lot closer, and the idea here is to bring the data as close to the customer as possible. That's what the edge is it's that threshold between where the data lies and where the customer is. So we're trying to bring the edge from where it is over here to all the way over here. And the goal really is to bring all these edge servers everywhere. So this slide that you see here, we've got these edge servers all over the place. They're not just in one location, but everywhere. And the point now is if you've got these clients now sitting in different places, no matter where they are, they're going to be pretty close to one of those edge servers. In this case, one of the Bluzelle edge servers. So edge computing, as you can tell, it's a fence, it's a parameter. It's about bringing that data that's available to the customer as close as possible to them. The closer it is to the customer, the faster the performance gets. So let's now talk about the edge. It's a new paradigm compared to cloud computing. So let's talk about the differences between the two. So what is the cloud? The cloud is about consolidating power, right? It's about using something like AWS or Azure or Google Cloud Platform and having access to those computing and networking resources in a centralized location called a data center. We're all familiar with that. The goal of edge computing is different. It's to move these resources away from those data centers and bring them as close to the user as possible. We already saw that with the previous diagram. So edge networks can interact with cloud networks. They're not mutually independent. You can have an edge network that has servers, nodes sitting on the cloud network and vice versa, or they can purely exist on their own. And that's where decentralization comes in, which we're going to talk about a little later. Generally, edge and cloud computing are opposites. Again, the cloud is trying to consolidate power. The edge is trying to move it out to the edge as close to the customer as possible. So let's talk about tomorrow. What's going to be coming in the future? So the next generation of applications that we see, that I believe in, are going to be needing the edge. And let's talk about why. Well, the next generation of applications are not going to be running necessarily close to these data centers. They're going to be running on those smartphones and on those IoT devices that are close to the location of the consumer. And they're much further away from where those cloud data centers are. Remember that those cloud data centers have to be physically set up in locations. They're expensive and time-consuming to set up. They're not necessarily always going to be close to where the people are. The data itself, therefore, needs to be more closer to the customer. It needs to be spread out all over the globe and on the edge. So this is where that opportunity comes in for businesses, where they can capture these new customers. But in order to do that, they really need to take advantage of the edge. They need to move their data to the edge. So let's look at this slide, and you can see that we've got these customers all over the place. We've got data sitting all over the place. How do we make sure that that data is available? Well, we've got to have those edge servers. We've got to have something like the Bluzelle Edge Cache available. The competitive advantage, I believe, in the future with these applications that are going to be coming out in the future that want to capture these new audiences, all these people in developing countries especially, but also the IoT devices, all those new smartphones, it's going to be coming about by having speed to access the application data and availability of the data. Let's not forget that it's not just about performance, it's also about making sure that the data is available, that servers don't go down, that when customers ask for the data, they can get access to that data. This actually means then that you got to bring the data as close to the customer as possible, ensuring it's always available. The users are not, as I said, the users are no longer going to be consolidated to just these developing nations and these metro areas. The users are not going to be spread out. They may not even necessarily be in big cities. They could be in villages. They could be far away from the metro areas. They could be in transit, and that's another thing. People are on smartphones. They're in transit. They're traveling. They could be all over the place. It's important for applications of tomorrow to be competitive by keeping these users connected as well. And the part of that is having access to the edge. And really, I see that with this large explosion of new devices, new users, there's going to be a lot of lucrative possibilities in the future. The developers of today, they really have to future-proof their applications. It's fine to be building an application today, but keep in mind where your application is going to go tomorrow, where your customers are going to be, where the new customers are going to be, so that you can have an architecture that adapts to the needs of your users in the future, the users that you want to get. So let's go to the next slide. So now let's talk a little bit about the blockchain and how it's empowering Bluzelle's edge computing network. So you can see on the slide here that there's really 4 areas that we're using blockchain and really decentralization to power our edge. Bluzelle itself, just to be clear, it's not a blockchain, but we're borrowing a lot of the concepts from blockchain and decentralization in order to make our edge product as competitive as possible. So let's start with decentralization. That's one of the key aspects of blockchain. It's one of the main aspects that makes blockchain so interesting, is that there's no special servers, there's no power authorities that power the network. Every single node in a blockchain network is expendable. What does that mean? It means that unlike traditional servers or networks where if a single server goes down, typically you could have a problem, with a blockchain, these nodes are more or less equal. If one of them goes down, the rest of them pick up the slack, and new nodes can join, nodes can disappear, it doesn't matter, they're all expendable. Bluzelle is using decentralization to provide availability to make sure that the nodes, all the Bluzelle nodes are equal. We can spin up nodes on the fly, and all these nodes have the same data. That's something we're going to move into. But ultimately, the point is that none of the Bluzelle nodes are special. They're all equally expendable. Reliability. So all the data replicated on Bluzelle is replicated across all the nodes within the network. This, and I'm kind of simplifying it, but basically Bluzelle has these things called swarms. So what I should say is the data is replicated across all the nodes in a given swarm. So what that means is even if a single server or a bunch of servers in a single swarm go down, Bluzelle will continue to run smoothly. And this is really a byproduct of decentralization. Security. So attempting to attack a server or even a group of servers on a swarm will typically fail. Again, it's because you've got decentralization, you've got a consensus within a swarm that prevents these attacks from being successful. And then availability. Bluzelle's focusing on high availability, which really means 5 nines or better, or 99.99% availability. And this comes down to robustness, making sure that not only is the data secure and available with speed, but it's actually available. We don't have situations where people are asking for the data and it simply isn't available because the network went down. So So that's really a big important aspect. There's no point in having high speed when your network's not available 25% of the time. I'm going to actually leave some time for questions at the end of this. I currently can't see the questions, so I will leave that for the end. So let's talk a little bit now about Bluzelle specifically, not just talking about concepts like blockchain and decentralization and the edge. So what is it that Bluzelle's edge cache is actually doing? So what is Bluzelle? We have a global network of edge servers, and we're using these edge servers to power the cache. So each of these edge servers are part of a swarm, and we have multiple swarms. What I actually have shown here, and it's not necessarily obvious in this diagram, but each of these icons here is actually a single swarm. So all the units within that icon are the nodes within a swarm. So actually what we have here is multiple swarms, and the idea here is your application can talk to a network of swarms. So Bluzelle is actually a collection of swarms, and nodes are within each swarm. So, you know, before Bluzelle came along, we had a traditional caching layer typically in software. People have probably used Redis. And what was Redis? It was the traditional caching layer. So if you had a single data center, you would have your database. You could put Redis in front of it. Redis would cache a lot of the frequently asked for data points, and typically Redis would respond to those requests instead of hitting the database. So that's what we call the traditional caching layer. It obviously had some major advantages. You wouldn't be hitting the database every time you were doing a request, especially if you're doing a multi-table join. Some of these can get very expensive. So having that request cached in Redis was a huge advantage. So that's a traditional caching layer. But really, now we're going to talk about the edge caching layer. And really, we've designed the edge caching layer to work with existing applications, but also new applications. And the idea here is you can take an existing application or a new application that might already have a traditional caching layer with Redis, and you can augment it by adding the edge caching layer. So the edge caching layer's goal is not to replace the traditional caching layer. It's an edge caching layer of its own, and its job is to improve performance far beyond what a traditional caching layer can do. The traditional caching layer is really just one place. It's sitting in one data center. Bluzelle brings it out to the edge. So what do we mean by replacing DevOps with NoOps? Well, the idea here is traditionally you had to run your Redis server, you had to manage it, you had to manage all your databases and all the connections, and if you wanted replication of your Redis between different data centers, you had to take care of that. So there was a very heavy DevOps effort required there. With Bluzelle, we're moving from DevOps to NoOps. The idea there is you don't need to have a staff managing all the Bluzelle servers because Bluzelle is managing it for you. In fact, we have a serverless paradigm where all you really do is you just use Bluzelle. You don't have to worry about where the servers are. You don't have to manage them, back them up, or do any updates. It's done for you. And that's what the NoOps paradigm is, where your staff is not taking care of that. And of course, as we already mentioned, we're using the best of blockchain technology, namely decentralization, to provide you with the high performance and availability. Those are the two key things that we see. Those are the two key things that people are looking for out of their cache. They want to make sure it's performant, and of course, it's always available. Now, Bluzelle has been working consistently with a Tier 1 communications network. That Tier 1 communications network allows us to have dedicated pipelines to connect all our nodes together. Just one moment. So I'm just going through the questions that we have listed on YouTube, and I'm going to start from the top. Who do you see as the biggest competitive ways? Is your approach different than theirs? It's an interesting question. I don't really look at us as competing directly with a company in crypto. Our goal here really is to provide an edge cache, an edge caching layer. It's a new sector. It's a new technology that we're seeing that developers are very interested in. And really, if there are competitors, they're not necessarily going to be in the crypto industry. There's already caches obviously available from Redis on the various cloud platforms. But like I said, what we're offering is an edge cache. So I don't really see a specific competitor in the crypto space for that. What might be the computational load and overhead of a swarm node running on an IoT or smartphone? That's a good question. The long term is I would like to see that an IoT device or a smartphone is running as a swarm node. That's something that's going to come further down the roadmap. The goal right now will be to have regular devices. When I say devices, PCs, not an IoT device or smartphone that will be they'll be running the nodes. So the overhead is obviously going to be pretty high. We do want to streamline that, and one of the things that we're going to have on the roadmap further down is kind of support for those sorts of devices. So that's going to come down the road. Is the edge meant to reach out as far as IoT devices? Well, hopefully. I mean, I don't think it's practical to expect the edge to reach right into the building where every single IoT device in the world is going to be. But our goal here really is to keep pushing that edge as close as possible. So ultimately, the average distance from a device to the edge where the data it's asking for is stored is as small as possible. Let's see here, we're back in action. I'm going to go back while I'm waiting for more questions and answer one of them that might have been missed due to technical issues. There was a question about the blockchain moving to edge computing. I really like that question. I think that the blockchain really already is edge computing. It's already using edge computing. If you think about Ethereum or Bitcoin, all these nodes are all over the world, and if you want to do a read or write, what do? You talk to any node. You can talk to the node closest to you and read data. You can write data, and if you write data, it propagates across the network. If you read data, it'll come from the node closest to you, whichever one you're talking to. And of course, that data was updated somewhere else, it'll propagate across the network. So it in itself already is an edge network, and I really like that question just because I think that blockchain is an example of an already existing network that uses edge computing. And do I see any real adoption use case of edge computing? I do. I mean, edge computing really can apply to a lot of existing applications. I'm interested in gaming. If you have an existing gaming application, it can already use the edge cache. Imagine that game is pulling data in from a centralized server or a collection of servers on the other side of the planet. Well, there's no reason why you can't start caching that data to the edge right now, and you can have your clients pull that data from the edge instead of waiting hundreds of milliseconds to pull that data from a centralized server. So there's already use cases for it. It's just a matter of adopting it. And one of the nice things is we've designed the Bluzelle toolkit, the API, so that you can augment existing applications, start using Bluzelle right away. You don't really need to rewrite a lot. In fact, we encourage people not to change your existing caching solutions. If you're using Redis or some sort of existing cache, keep using it and use Bluzelle on top of it. Bluzelle's point is to accelerate, speed up, improve the performance, and add availability to existing applications, not replace their existing caches. Another question from the community. How do you ensure all the data is synced in real time if the data is all processed at the edge? Will it be slow? We found that there's about 850 millisecond delay from the time when data is written to when it propagates throughout the network. So that's actually quite comparable to the speed that I've seen when you're looking at a key value store from other companies. Google has one, Cloudflare has one with Workers KV. What we have is quite comparable. And we're using, one of our main focuses is really about having the fastest consensus algorithm possible so that when data is being written, it syncs as fast as possible across the network. That's actually one of our top areas of research, is ensuring that synchronization is fast. How do tokens come into play? So that's something that's not really in the scope of my conversation today, but we will be adding token economics further down the road. The roadmap indicates that it will be towards the end of the year, and that's when you'll be seeing tokens used for payments, as well as compensating farmers who are joining the network. There was a question earlier that may or may not have gotten through when we had some difficulty with our connection, but the question was from Monty, which was, why aren't big cloud storage companies like Google or Amazon adopting edge computing? I think they are. In that, well, I shouldn't say it's edge computing. They're adopting serverless computing. Google and Amazon are operating cloud data centers. They can't technically really adopt edge computing, because edge computing, as per the definition we've been describing, is about moving the edge way beyond where the cloud data center is to much closer to where the customer is. You can't set up data centers everywhere in the world. There's limitations. Bluzelle is moving that edge beyond the cloud, closer to the customer. So in my opinion, the cloud computing companies are going to be limited to wherever their data centers are, and that's where Bluzelle comes in. We can move that edge much closer to where that customer is. There's another question here now. Are there any companies using your tech already, or are there still some regulatory hurdles to overcome? We have companies that are moving into using the project as a pilot. So our mainnet's going to be coming out, and we're going to be having initial customers coming in, and they're going to be using the tech. As far as regulatory, I can't see any regulatory hurdles. I mean, we are providing software as a service, infrastructure as a service, so this is not really subject to any regulatory, as far as I know. Definitely, if you're talking to a company in terms of tokens and about other areas in financials, that's a different question. But this is a software, so we're not really too concerned about regulatory there. The actual question is, how do you guys generating income at this moment in the coming years? So that really is something that's going to be coming down the road. I mean, right now for the mainnet that we're launching, income's going to be coming through people paying for the service. So if you're signing up to use Bluzelle, you'll be paying to use the service to store your data there and for reads. Towards the end of the year, when we have token economics coming in, obviously the token's going to come in, and that's going to play a bigger role in terms of income and the flow of value between users of Bluzelle and the nodes that are providing the services. Question here, how will Bluzelle Edge nodes handle security and privacy content issues? So Bluzelle specifically does not protect data from being read, just to be clear. We don't have a mechanism where you have to authenticate and prove who you are to read the data, and the reasons might be obvious. The data is being stored on nodes, and we're not trying to protect the data on nodes, because ultimately those nodes could, in the future, be run by members of the public. So we're not doing that. The main thing that is protected is rights. The idea being that we want to ensure that if you have a namespace of key value pairs stored on Bluzelle, nobody except authorized owners of that data can write to it. So that's dictated by the private key. So if you own the private key to your namespace, you can write to that data. If you don't have the private key, you can't write, and that ensures the authenticity of the data. So if anybody's reading from that data, they know that only you, the owner of that private key, could have written to it. But as far as reads are concerned, it's up to the application, the data owner. If you want to protect that data from reads, you can obviously encrypt that data at the application level, but Bluzelle doesn't currently natively encrypt data for you. That is something that is an item on the roadmap, and it's one of our research topics. So I think we're done. So thank you very much again for attending, and for all the delays, putting up with all our delays. And yeah, hopefully we should have a recording of this up soon with fixes in place for all our delays. Thanks again.